we're going to write out some formulas for a bunch of different compounds. And we're going to start by looking at this one right here. We'll start with the name. Let's start with the formula on this. Formula is
NaCl.
NaCl, which we call
Sodium chloride.
sodium chloride. Now, this is a type of compound that we call a binary ionic compound. And binary ionic compounds, let's just list this up here, binary ionic compounds, will always follow this naming scheme. And that is, the metal will retain its name, and we say that the nonmetal, we say that this retains its stem name, or your book calls it the root name, onto which we add a suffix of IDE. So it retains its root name, onto which we add a suffix of IDE. Now this root name right here, this is the first one or two syllables of the element's name. The first one or two syllables of the element's name. So we talked about the root name of, oh, where do we have it? Here we go. We talked about the root name of chlorine. The root name of chlorine would be chlor. And so we have chlorine, chloride, chlorate, chlorite. The root name of bromine would be? It wouldn't be bromine, it would be brome. So you have bromine, bromide, bromite, bromate. The root name of oxygen would be? Ox. And so we'd have oxide. Sulfur would be? Sulf. And so we'd have sulfide or sulfate. So, with that in mind then, we should be able to name something like this. Let's say that we have Al2S3. Al would be aluminum. And last part would be sulfide. Aluminum sulfide. Because again, this is a binary ionic compound, and in binary ionic compounds we always add on a suffix of IDE. If we have Ba, Br2, this would be barium bromide. Good. Barium bromide. And if we add Na3N, Na3N would be
Sodium
nitride. Yes. I know a lot of people want to say nitrate, but nitrate is something else. This would be sodium nitride. Going the reverse direction gets to be a little bit more involved. And going in the reverse direction, we need our periodic tables. And that's because we need to know what the charges are. Because the next thing we're going to do on here is to write out a formula. So let's say we want to write a formula for something like lithium fluoride. Lithium fluoride. Lithium fluoride. So to do this one, we need to know what the charges are based on position in the periodic table. Everything in group, and here's a little mnemonic, this makes it easy. Everything in group 1A in ionic compounds has a 1 plus charge. Everything in group 2A has a 2 plus charge. And most of them in group 3A have a 3 plus charge. And those are for your metals. If we go for the nonmetals, elements of group 7A have a 1 negative charge, group 6A have a 2 negative charge, and nonmetals of group 5A have a 3 negative charge. Now the metals are easy because their charges are related to their group numbers. For the nonmetals, here's how the mnemonic works on here, and it will only work for those that have had some chemistry before, but we will be having that chemistry at all the rest of us here in another couple weeks. But when elements form compounds, there's a magic number that elements try to attain in the outer level. That magic number is 8. Right. Think of the magic 8 ball, if you ever heard of the magic 8 ball. So that's the magic number. And so if this is in group 7A, it needs 1 more to make 8, and it's a 1 negative charge. Group 6A needs 2 more to make 8, and group 5A needs 3 more to make 8. So we get a 1 negative, 2 negative, and 3 negative for these charges. And we'll talk about that magic number here a few weeks down the road. But if we wanted to look then at something like lithium fluoride, we look at where they're located in the periodic table. We see that lithium would have a charge of 1 plus. Fluoride's charge is how much?
1 negative.
1 negative. So we have Li positive, F negative. Now our objective is to balance charges. We want the total of the positives to equal to the total of the negatives. And what does it look like here?
Balance each other out.
Already balanced. So the formula would be LiF. If we wanted to look at something like sodium sulfide, we go to our periodic table. Sodium always has a charge of how much? 1 positive. Sulfide would always have a charge of 2 negative. So again, charges. Sodium is a single positive. Sulfide is a 2 negative.
So we would need 2 sodiums for every 1 sulfide.
That's exactly how you need to think about it. You need 2 sodiums for every 1 sulfide because we want the total of the positives to balance the total of the negatives.
So it would be Na2S.
Na2S. That's how this works. When we write out the final chemical formulas, remember that subscripts, the numbers on the bottom, represent a count. So this tells us we have 2 sodiums for every 1 sulfur. And if anybody has any questions, just stop us or we'll look at some more examples. Strontium iodide. Strontium, from the periodic table, has a charge of how much?
2 plus.
2 plus. Iodide,
1 negative.
1 negative. So strontium with a 2 plus, iodide with a 1 negative. Okay, now which one do we need more of?
SR I2.
And which one do we need more of though?
Iodide.
Iodide, right. So we put in the iodide here, and then we have the 2 iodide ions to balance the strontium. The formula would be SR I2. Any questions yet? So then, we're almost done here, guys. I know you're looking at that snow and you want to get out and play. Magnesium, I do. Great skiing. Magnesium sulfide. Magnesium, based on its position in the periodic table, has a charge of how much? 2 plus. And what did I pair this with? Sulfide?
Yes.
Charge is 2 negative. So Mg with a 2 plus, sulfide 2 negative, balances each other, so its formula would be MgS. One more example, and we're going to have you try a few yourself. Aluminum oxide. Aluminum oxide. We go back to the periodic table. Aluminum has a charge of 3 plus. Oxide would be 2 negative. So, Al with a 3 plus charge. Oxide is O with a 2 negative charge. Here's how we handle this one. Here's another term. If we go back, hopefully it doesn't scare you too bad. Least common multiple
6.
is 6. So least common multiple between 3 and 2 is 6. So how many aluminums do we need to get 6 positive charges? And how many oxides do we need to get 6 negative charges? So you see here what we're doing, we have 6 positives balancing 6 negatives. So the formula for aluminum oxide is going to be Al2O3. Or again, the subscripts are a count of the number of ions. We have 2 aluminums here for every 3 oxygens. Also notice that the final chemical formula does not show any charges in them whatsoever. If your high school teacher let you do that, your high school teacher let you do it wrong. So we do not write charges in the final chemical formulas. So let's try these. And these are going to show up in your Socrative app and give you a chance to talk. If you see a formula, write the name. If you see a name, write the formula. First one is Li2S. Then we have Ca3N2. Then we have potassium phosphide. And then barium oxide. So once again, if you see a name, write the formula. If you see a formula, give the name. Talk, help each other out if you need to. And I have the first one loaded up here in the Socrative app. Compare some answers before you enter them in. I think this first one's an open answer, not multiple choice. And if you have that one already entered, then look at the next ones coming up. Next one is, what was it? Ca3N2. So I'll give you about 15 seconds on this first one. Does yours mark it right or wrong when you answer? No? Okay. Wow, here we go. Correct one is lithium sulfide. Good job, lithium sulfide. Next up, the name of the compound with the formula of Ca3N2. This one is multiple choice. Ca3N2. And while you're entering that, I have a couple bonus problems I'm going to write in up here. And we'll go ahead and check the answers. We'll go 5 more seconds. 5, 4, 3, 2, 1. Correct one is choice A, calcium nitride. Remember, we haven't even learned about 8s really yet. Binary ionic compounds always have an IDE suffix. Always have an IDE suffix. Next one is potassium phosphide. Write out its formula. And if you have those done, I have a couple bonus problems up here. The last two. So I'll give you a bit more time. We'll take about 5 more seconds. Lock in an answer. 5, 4, 3, 2, 1. Correct one is choice C, which is K3P. And that comes from the fact that potassium has a charge of how much?
1.
1 positive. Phosphide is
3 negative.
3 negative. So if we have a single positive and a 3 negative, how many potassiums do we need? 3 of them to balance the charge of the 1 phosphide. Its formula would be K3P. And then the last one here. Write the formula for barium oxide. Write the formula for barium oxide. And if you have those done, I have 2 bonus problems right here. All right, we'll take about 5 more seconds. We'll go 5, 4, 3, 2, 1. And we have a little variation here, but looks like the majority of us are correct. Some of you just put in B, which is not barium, that is boron. The correct answer is BaO. BaO is the correct choice. And if we want to do this one here, we look at barium on the periodic table. Barium is located here. Its charge is always 2 plus. Oxide is 2 negative. With a 2 positive and a 2 negative, what happens? Formula then becomes, right, BaO. Anybody know BaNa2?
Banana.
Banana. How about that? Isn't that great? Banana. And you get that, of course, because it's a, yeah, but you have a metal with a metal, and that's not a compound. I know, that's our signal to get out of here, right? All right, our last one. Now this one you just got to actually say the formula. No, say the formula. K9P, also known as dog urine. All right, that's it here for today, guys. Be careful out in that snow.